We now go over some questions on trig equations. And the first one we've been given is cos squared x minus sin x minus 1 being equal to 0. We want to solve where the solution has been limited, and so whenever we are solving questions, we need to pay particular attention to the conditions that have been given. Other times we might answer, of course, what is right, but it's not what is expected of us. And so we want to solve cos squared x minus sin x minus 1. Our answer should only be between 0 degrees and 2 pi. And this 2 pi is 360 degrees. Actually, this is equal to, we can even include the 360 if it is there. So the first thing in the state in which this question is, we cannot solve it the way it is, because we've got a combination of cos squared and sine which is not possible to solve, and so we want to make them to be the same. But we know that cos squared is going to save us from the very important trig identity. Sine squared x plus cos squared x is equal to 1. And so if we make cos squared x subject to the formula, this will give us 1. We take the sine to the other side, minus sine squared x. And so where there is cos squared x, we're going to substitute 1 minus sine squared x. And so that gives us 1 minus sine squared x. And then we've got a minus sin x, and then minus 1, and that is going to be equal to 0. Now notice that this is positive, negative 1, this is positive 1, it cancels out. So we remain with negative sine squared x minus sine x, and that is equal to 0. Now at this point, what are we going to do? What we do is we're going to factorize out something here. Okay. So of course we have got sine squared and sine. We are able to factorize out at this point. Now what really are we going to factorize out? We can remove a negative sign. So if we remove a negative sign, here we have got 2 signs, so we're going to remain with 1, so that will be sine squared x. Because we've removed the negative, so what will remain here is a plus 1, and that is going to be equated to 0. So therefore what we are going to have is negative sine x being equal to 0, or sine squared x plus 1 being equal to 0, like that. Anyway, let me not take this form because we might reach at one point where we might not be able to simplify. For a reason, because I'm seeing a square root of a negative number. Let's see if we can't avoid that one. What if we just remove sine x? And so what is going to remain here will be negative sine x, and then that will be minus 1. I mean, this will be sine x. So even the one which we did earlier was supposed to be just correct because I had put a squared which I wasn't supposed to put there. Okay, so I'll go back now to the one which I wrote. So this is a negative that I've removed, and so we're going to remain with this sine x, not sine squared. And then now this will be a plus 1, and that is now going to be equal to 0. So this will give us negative sine x being equal to 0, or sine x being equal to, so if we equate this to 0, then it will be equal to negative 1 because we've simply taken the negative 1 over the other side. So that will be equal to negative 1. So if we divide by a negative 1, so that we remain with sine x, it gives us sine x is simply still 0. And then this side, we have got sine x being equal to negative 1. Now for us to remain with x, what we are going to do is we are going to take the sine inverse of 0. So taking the sine inverse, we can also say arc sine 0. So this is the same as saying sine inverse of 0. So there is no difference. Now if we consider just, of course there's necessarily no need of using a calculator. If we talk of 0 degrees for sine, so sine x, the sine curve starts at 0, it goes up, it comes down, and then it comes there. So where it is cutting here, this is 2 pi, that is 360, and then this is pi, which is 180, and also at 0. So where sine is 0 is at 0 radians, pi radians, and 2 pi radians. And so this is giving us x to be equal to 0, pi, and also 2 pi. just for the first portion. What of the opposite portion there? So we're going to say x is going to be the sine inverse of -1. Alright, so we're going to take now the sine inverse of -1. If again we want to sketch the sine graph, it goes in that manner. So where it is going to give us a -1, let's say we just press on our calculators the sine inverse of -1. So that is supposed to give -90. Even without using a calculator, if you see this sketch which I've shown, the highest point of a sine graph is 1. The lowest point is -1 in that manner. So at this point, if you are talking about a -1, of course a -1 makes it tends it I mean it cuts the sine graph at 270 degrees, a -1. If we take the sine inverse of -1 direct, we are going to find the negative answer. It will be -1. But when we are working with this, to avoid these negatives, what you first do is, since we are solving for x, let's just say alpha, and then we take the sine inverse of a +1 instead of -1. And then the sine inverse of a +1, as we can see, is going to give us 90 degrees. But of course we don't want the sine inverse of a +1. We want the sine inverse of a what? Of a -1. So what we are going to do is now we go on our quadrants. So following the all students take coffee, we are going to look for quadrants in which sine is negative. So sine is negative in this quadrant and also in this quadrant. So whenever we are finding angles in the third quadrant, so the acute angle that you would have found, now this is 90 degrees. So the acute angle in this, so this is even not an acute angle, so that is a right angle triangle. So that is in the third quadrant, and we find that the angle that you found is actually just this one, like that. Anyway, if we didn't know that, we go to the third quadrant where tan is where sine is negative, because remember we're talking about a -1, that's why we are going to that quadrant. So we're going to go to all quadrants where sine is negative. In the third quadrant, whenever you are finding a value, what you do is you are going to add to 180 the alpha that you found, the acute angle that you found, and so that is going to give us 180 plus, now in this case we found 90 degrees, so that is going to give us 270 degrees, which I was trying to explain here, like that. Now of course, notice that we are not giving our answers in degrees, we are giving our answers in radians. What is 270 in radians? So 270 multiplied by pi over 180, so this is the same as the 3 pi over 2 radians. So this is the first answer, x is equal to 3 pi over 2. And then the second one, it is in this quadrant. Now in the fourth quadrant, whenever we are finding x values, from 360 we remove the alpha that you have found. Now notice that we found 90 as the alpha, so that will be 360 minus 90, which will still give us 270. So we only have one value. Okay, so that is why we saw for the sine graph it goes like that. If you take a sine of a -1 here, the only value that you are going to find is here, which is at 270 degrees. So now we can put our answers all together. So our answers, remember the solution set has been given is from only 0 to 2 pi. So we're going to say, therefore x is going to be equal to, start with the smallest one, which is 0 degrees, which we can see here. Then the next one is 180, which we can see there as a pi. From 180, the next one is 270, which we can see there as the 3 pi over 2. And then the last one is a 360, which we can see as a 2 pi. So these are the solutions then written in that form. Alright, let's consider the next question that we have in this tutorial. So we've been given cos 2x plus 3 sin x minus 2. We are also following the same condition as the previous one. We want answers between 0 and 2 pi. Now considering this again, we have got a mixture of cos and sin, but here it is not cos squared, it is cos 2. So for us to tell what we are going to substitute there to make it the same, we are going to use a certain identity. When we are talking about cos, let's say cos A plus B. If we want to expand this, what we do is we just take cos, we take the first number which we have, which is A, the first angle, and then we take again cos, we take the second angle which we have. If it was plus, we put a minus. If it was minus, we put a plus. But in this case, it was a positive, so we're going to put a negative. And then the ratio changes, we are going to be using sine. So it becomes sine A and also sine B. Now, if these were the same, if this was also A, that means even this portion here is going to be A, even this portion is going to be A. So that gives us cos 2A, because the A plus A can add up to give us 2A. Now that gives us cos A, which we can also say as cos squared A. And then minus here we have got sin A, which is sin squared A. Now notice that we are talking of cos 2A. Now our aim is to make it in the form where it is going to have sine. So we don't want to have this cosine squared. And what do we do in that case? We know that cosine squared A plus sine squared A is equal to 1. So making cosine squared A the subject of the formula, that gives us 1 minus sine squared A. So where there is cosine squared A, we are going to replace with 1 minus sine squared A. So that gives us, we just pick this cosine 2A, that is going to be equal to 1 minus sine squared A, and then minus, so we've just replaced here with this, and then minus sine squared A again. That means cosine 2A is the same as 1 minus, we can subtract this to negative sin squared A minus sin squared A will give us negative 2 sin squared A. So where there is cos 2A, we can replace with this. So that will give us 1 minus sin squared. But here we're not using A, we are using X, so that becomes X. And then now plus the 3 sine X minus 2, and that is going to be equal to a 0. Okay, now at this point which we have reached at, what we are going to do is we are going to add the like terms. So what I can do is we have got a 1 and a negative 2. That is going to give us what? A negative 1. So we are going to have negative sin squared x and then plus 3 sine x and then minus 1, and that is going to be equal to 0. Now at this point we have got a quadratic equation. This one is squared, this one is in power 1, and then this one has got no x on it. So what we are going to do is we find the product. The product, we get a negative 1 by negative 1, which is going to give us a 1. Okay, and then the sum is going to be equal to, what we are going to get is simply this number which is here, which is a 3. And at this point I realize I even left out something. Okay, so let me just go back to what I've left out just a bit. So just at this point, we are saying where there is cos 2a, we are replacing with 1 minus 2 sin squared x. We already derived this. And then we are saying plus 3 sin x minus 2 is equal to 0. And so now this gives us 1 minus 2 sin squared x plus 3 sin x and then minus 2, that is equal to 0. So I left out a negative 2 there, and then plus 3 sin x. Now we are saying 1 minus 2, that is a negative 1, and that is going to be equal to 0. So we find the product here, negative 2 by negative 1, which is positive 2. And then the sum is, we just get this one, which is here, which is a 3. Now we're going to look for a factor. What two numbers can we multiply to get 2? And if we add them, we get 3. That is basically 2 and 1. 2 times 1 is a 2. 2 plus 1 is a 3. So we're going to write this as negative 2 sine squared x. And then where there was this on the middle, we are going to put first 2 sine x, and then we are going to put sine x, and then minus 1, and that is going to be equal to 0. So at this point we can factorize them like that. So we can remove, of course, a 2 and a sin from the first 2. So if we remove a negative 2 sin x, what we are going to remain with is sin x plus, it becomes minus because it was positive here, but we've removed the negative, so it becomes minus 1. And then from the second part, for us to factorize, what is common there is simply a 1. So that still remains sin x minus 1, and that is going to be equal to 0. So we put those which are outside together, we get the 1, and then we get this minus 2 sin x. And then we get what is inside, that is a sin x minus 1, and that is going to be equal to 0. So at this point we can equate each of them to 0. So the first one, 1 minus 2 sin x is going to be equal to 0, or the sine x minus 1 is also going to be equal to 0. I can take it on top for more space. So what I'm going to do is I'll take this one the other side, so it becomes negative. So I'm going to have negative 2 sine x is equal to negative 1. So I'll divide by a negative 2, and so I'll remain with sine x is equal to 1 over 2. And then the other one, if I take the 1 over the other side, what I'm going to have is sine x is equal to, it becomes positive 1. Now after finding this, the next aim is now to find the value for x. And x is equal to arc sine 1 over 2, which we also call as sine inverse 1 over 2, which is the same thing. Now we know that sine 30 is half. So that means sine inverse half is going to give us 30. So basically that's how they work. If sine of 30, this is a special angle, gives us 1 over 2, then sine inverse of 1 over 2 is going to give us the 30. And so we are going to take it. Now 30, of course we are working in radians. 30 in radians we multiply by pi over 180. So the 0 there, the 0 cancels. 3 into 18, that should be a 6. So 30 is pi over 6. So that is the first angle that we find. So this is the angle in the first quadrant. Now note that it is positive. So in the first quadrant, so what we have is this. In the first quadrant we have found 30 degrees. Remember, sine is also positive in the second quadrant. So what will be the value of sine in the second quadrant? So what we want to take is this angle in that manner up to that point. So this is also going to be 30. So all we say is that when we are talking about angles in the second quadrant, for you to get the value for x will be equal to 180 in this case, which is pi. In radians 180 is pi. And then you remove the angle that you found in the first quadrant, which is the pi over 6. Now we know that pi over 6 is 30. 180 minus 30 is 150. And 150 converting into radians gives us 180. We multiply by 180 over pi. Pi over 180. So this 0 goes with that 0. We know that 5 can go into 15 3 times. And then 5 can go into 18. No, it can't even go there. So what we are going to use is the 3. Okay, 3 into 15. a bit goes there 5 times, and then 3 into 18 goes there 6 times. Of course, we could have just done it here, pi minus pi over 6, which would have given us 5 pi over 6. So this is the first angle that we found. Okay. And then for sine x, so to find the other angle, x is going to be sine inverse 1.
Okay, he's saying you come.
So sine inverse of 1.
He's saying you come to the room. So I tell him to come on.
So when we are talking about 1,
Okay.
sine of 1 gives us, we can see the angle there. Okay. Sine inverse of 1 is going to give us 90 degrees, as we can see from this. We can even confirm that by pressing on a calculator. That gives us 90 degrees. And we can convert 90 to radians by multiplying by pi over 180, which is simply pi over 2. So that is for this portion. It has given us pi over 2 alone. So even if we try to do anything else, the other angle is also going to be 90. And so now we make a conclusion. So we are going to say, therefore, our x is going to be equal to, the first angle that we found was 30. So we just write them in order. Pi over 6. The next one we found is 90, which is pi over 2. And then the other one we found was 150, which is 5 pi over 6. So those are the values then that we are going to find. Okay. Having another question. Been given 3 cos 2x minus pi is equal to 3 over 2. How do we find such equation? How do we solve it? Okay. So we go on to solve this question. 3 cos 2x minus pi is equal to 3 over 2. Now the first thing that we are going to do is, we can see that we have got a compound angle. That's why we can see this addition and subtraction inside there. That's a compound angle. So what we do is, we are going to first divide by this 3 on both sides. So that is going to leave with cos 2x minus pi, and that is going to be equal to 3 over 2 divided by pi. This is the same as multiplying. Instead of dividing, it's the same as multiplying by 1 over 3, which is going to give us simply 1 over 2. Now at this point, we are going to take this as one angle. Let's take it as one angle. So that is going to give us, let's say, let 2x minus pi, let's say, be equal to alpha. So that means this is going to be cos, where there was 2x minus pi, we're going to put alpha, and then that is going to be equal to 1 over 2. And then to find alpha, alpha is going to be equal to cos inverse of 1 over 2. Now 1 over 2 is a special angle, it comes from a special angle. And we know that if we talk of cosine of what? Cosine of 60, it gives us 1 over 2. So cosine inverse of 1 over 2 is going to give us 60. Now 60 in radians is the same as, so pi over 3. So this is going to give us pi over 3 as the first angle. Alright, now finding pi over 3, the next one, since we are talking about a compound angle here, and remember we are talking about a compound angle and there is a double angle which we can see at that place. Okay, because of that double angle, before I even do anything, let me first find the next angle that we are going to have. So cos, in the first quadrant we have found 60 degrees. We know that cos is also positive in the fourth quadrant. Now what will be the angle in the fourth quadrant? And in the fourth quadrant, how do we find angles? So alpha is going to be equal to you just remove from 360 the angle that you have found, and in this case we found 60, so this is going to give us 300. Now we convert this 300 to radians by multiplying by pi over 180, so that 0 and that 0 cancels out. Okay, so 30 over 18, that gives us 5 pi over 3, so that is the other angle, 5 pi over 3. Alright, so after doing this, we are now going to bring back, remember we said just let alpha represent this portion. So since alpha is representing that portion, what we are going to do is now we take back the 2x minus pi to be equal to first pi over 3, and then the same also is going to be equal to 5 pi over 3 in that manner. So from this point, what we are going to do, we are going to take the pi that side. If we take that pi the other side, we are going to have 2x is equal to, it will be now pi is going to add to pi over 3 plus pi, which is going to give us 4 pi over 3. And then this same pi is also going to add to 5 pi over 3. So we're going to have 2x being equal to 4 pi over 3, and also that is 8 pi over 3. Now after finding this, notice that this is a double angle. The reason as to why we can see a 2 there, that is representing double angle. And so to each of these, we are going to add 360 degrees. So to the first one, we are going to add 2 pi, which is 360. So that will be 4 pi over 3 plus 2 pi, which is going to give us what? 6. That will be 10 pi over 3. And then to 8 pi over 3, we are also going to add 360, which is 2 pi, and that is going to give us 6. That will be 14 pi over 3. And then all these angles that we found, remember this is 2x, but we don't want 2x, we want to remain with x. So we're going to divide everything by 2. So if we divide this one by 2, this becomes 2 pi over 3. If we divide this by 2, it becomes 4 pi over 3. If we divide the other one by 2, it gives us 5 pi over 3. And then the other one gives us 7 pi over 3. So just to test, you can just get one of these angles. Let's say 7 pi over 3. You come and put it where there is x there. So we are saying it is going to be 2 times, where there is x, I put 7 pi, which is 7 pi over 3, and then we are removing pi. So what I've gotten is 8.37. Remember, this is in radians, so our calculator should be in radians. Otherwise, if you use it with degrees, it will not be the same. And then we say cos, what I've found after punching there, it is giving me negative 0.5. And then that we are multiplying by 3, which is giving me, okay, let me just repunch that. Perhaps we are wrong. Alright, so we are saying 3 cos 2, where there is pi, we are going to put 7 pi over 3, and then minus pi. So if we multiply now 7 times, 2 times 7 pi, that would be 14 pi divided by 3, and then minus pi. And then we say cos that answer, which is 0.5, and then 0.5 multiplied by 3, which is 1.5, and 1.5 is the same as 3 over 2, so that is correct. Alright, so you can test any of those values. Now make sure that these values are between 0 and 2 pi. So notice that all these values, if you convert them to degrees, they are not greater than 360. For example, the first one, convert it to degrees. That is 2 pi over 3, just multiply by 180 over pi. This pi and the pi cancels. 3 into 18, that would be 6, so that would be 60 multiplied by 2. So the first one is 120 degrees, and then the second one, which is 4 pi over 3 multiplied by 180 over pi, which will give us 3 into 18 is also 60 multiplied by 2, which is, multiplied by 4 now, which is 240. And then let's go to the 5 pi over 3. 5 pi over 3, we are multiplying by 180 over pi, and that is going to give us 3 into 18, that is still 6, so that is 60, and then multiplied by 5, that is giving us the 300 degrees. And then the last one, which is 7 pi over 3, we multiply by 180 over pi. So what we are saying is the pi and that pi is going to cancel, so that will be 7 multiplied by 60, which is 420. So the last one will not be included because it is out of our range, unless if they gave us a limitless range. But because the range was limited, the last one is not going to be part of our solution, so no, only up to this point. Alright, let's consider also the last question here. Told us to solve the equation. Now for this one, they've told us it's between negative 180 degrees and 80 degrees. So this one, as we can see from the condition, so we should give our answer in degrees. So we start cos x cos 30. Just from this, we know the meaning of cos 30. Okay, cos x cos 30. And then, so just from what we've been given here, this should tell you that it came from cos, the first angle was x, and then plus 30. And that is 1 over 2. So this is where it came from. So it's not that cumbersome to know this. This is the cosine identity. That is how we expand. So if it is negative here, then it becomes positive there. So now we're going to take cos on both. We are going to take the cos inverse of half. So that will give us x plus 30 is going to be equal to cos inverse of 1 over 2. So that will give us x plus 30 is equal to, what is the cos inverse of 1 over 2? That is 60. Okay, that is 60. Now, because we're talking of cos is positive also in the last quadrant. And in the last quadrant, how do we find the values? Is 360 minus the angle that you found, that is 300. Now, we want to remain with x. So we're going to take x 30 the other side. So that will be 60, it becomes negative 30. And also 300 also becomes negative 30. So our x is going to be 60 minus 30, which will be 30 degrees. And then 300 minus 30. That is going to give us what? That is going to give us the 270 degrees. Now notice that we only want between negative 180 and positive 180. So if we come on our quadrants like this, if we find 270, so 270 positive angles go in this manner. So this is our 270. But because it is out of our range, then we are going to, they've allowed us to use negative angles. We are going to move in the opposite direction. So 270 is the same as negative 90. So instead of writing this, we're going to write negative 90. And so therefore, our x is going to be equal to negative 90 and also 30 degrees. These will be our x values. And that marks the end of the class. Thank you so much for watching the video. Stay blessed.